Let's read these real-world applications of quadratic functions about number 87, all right? Aiden, let's go ahead and read it first. Thank you.
Find the dimensions of a rectangular coral producing the greatest enclosed area split into 3 pins of the same size given 500 feet of fencing.
Thank you, all right? So again, the shape is rectangular, right? We have to find the dimensions, okay? What else? You have to find the what? The greatest enclosed area, right? Where this is split into how many pens? 3 pens, right? Of the same size given 500 feet of fencing. Good. So we have circle the numbers, right? What are those? 500 feet of fencing, right? That means the fence and the 2 partitions in there, right? So talking about the perimeter, okay? Underline the question. What are the dimensions, right? The length and the width, right? Typical for a rectangle, okay? What else? We have boxed the keywords. So that's a rectangle split into 3 pens of the same size, and again with 500 feet of fencing, right? So definitely this fencing will talk about what? The perimeter. Are we good, guys? Right. So with that being said, let's analyze this one now with an equation. Get it? Okay, so let's put it in here. How do we visualize first, right? How does it look like? Okay, so with this being said, let's draw a rectangular pen like such, right? Where this is the width and that is the length. Get it? Right? We have split it into 3 pens. So that means you have partitioned this one. There's a separation in here. Yeah. Are we good? Okay. What else? Well, if that is the width, then definitely the area, the length of each of these partitions will basically the width, same width as the rectangle. Get it? Right? And how many lengths do we have? We have 2 lengths as well, right? So we have, for the entire fencing, that's why we have what? 2 lengths, right? And 4 widths altogether. We good? Right? So with that being said, then that means just for the fencing itself, right? Then that means what? 4 widths. Get it? Okay. Plus, how many lengths? 2 lengths, right? Is equal to, how much fencing did we use? 500 feet of fencing, okay? Get it, guys? And then from here, we can solve for whichever we want, right? Do we want the width or do we want the length, right? Doesn't really matter, right? You good? So in here, what do you think is the best thing to do first? Well, then since everything is divisible by 2, just simplify, divide everything by 2 first, right? So let's do that one for now. We're doing this one to simplify the entire expression because all are even anyways, right? So 1/2 of 4, right? Yeah. What's this? 1/2 of 2L. What's that gonna be? Emma, 1/2 of 2L. 1L, very good. And this one, half of 500. Travis. Mason, sorry. We good? Well, the easiest to compute is length, right? And how do you solve for length in here? Jaden.
I have a question.
Oh.
Why do we multiply by 1/2?
We multiply it 1/2. A very good question, Madeline, right? We multiply it 1/2 simply because we already noticed that, well, everything is divisible by 2 anyways, right? So to actually further simplify it, dividing it by 1/2, well, multiplying everything by 1/2 would basically just give you an L, and it's easier to solve for L. Got it, Madeline? All right. So it depends on your strategy, right? Very good. Get it, guys? Okay. But anyways, how to solve for length in here? Jaden. Subtract 2W. There we go. There we go. So this will cancel out. Length is equal to what? 250 minus 2W. And again, we're gonna use that one as our tool later to analyze that one, right? Now, what is our goal for such? You want to have a greatest enclosed area, right? So you want to what? Maximize area, right? So this kind of optimization problem, you want to what? Your objective is to what? What is the greatest area if your fencing is just gonna be what? 500 feet, right? Obviously, if you don't have any concern about the lot available for you guys, right? Like, okay, it's a free lot, right? Just you're given a 500 feet of fencing. What's the best dimension for you? That is of a rectangle, definitely, all right? So with that being said, what we're gonna do? Well, your objective is what? Maximize area, right? And again, how to get the area of a rectangle? What do you do with the length and the width typically? Multiply them together, right? Very good. So length times width is equal to length 250 minus 2w, right? And the width is basically just w. Get it, guys? Right. So with that being said, you can just graph it right away or do it algebraically, right? Your area will be what? Negative 2w times w, that will be negative 2w squared, right? Okay. Plus, what's this? 250w, right? And as you may see, what is this? What form is this one? Quadratic form, right? What quadratic form is it? General or standard form? Well, general form, right? Very good, right? ax squared plus bx plus c. Are we good, guys? Right? So with that being said, let me just erase this one in here, guys, okay? What part of a quadratic function will always give you the minimum or the maximum? What part of a graph will always be the minimum or the maximum, guys? Vertex. Very good, right? So with that being said, to get the vertex, what's the x-coordinate of the vertex? Your h. What's the form again? Negative b over 2a, right? Get it? Okay. And what's that going to be? Negative, what's your b? 250, right? Over 2, and your a? Negative 2. Okay. Right? And what's that going to be on your calculator? Yeah. 250 divided by 4. Right? There we go. What's that going to be? Use your Desmos, use your TIs. Magnolia, what you got? 250 divided by 4. 62.5. So what is that 62.5? Is it the length or the width? Width. Right? So if that is the width, what do you think is the length? Well, we're going to substitute it back in here, right? So length is equal to what? 250 minus 2w, which is what? 62.5, right? And what's that going to be? On your calculators, 250 minus 2 times 62.5. Cecilia, what you got?
125.
125. And again, all of these are in what? Feet, right? So this is the length, and this is the width in feet. Are we good, guys? All right. So with that being said, finally solving for it, right? So solution, what's the question? What's the dimensions, right? So the dimensions is what? Well, there it is, right? It's what? 125 feet by, what's this? 62.5 feet rectangular coral. Get it, guys? Okay. Well, let's see. How much will be its, let's go back to Desmos and verify our answer in here. Here it is. Going back to our Desmos, here it is. What's the area once again? 125 by 62.5. Right? That's what? 7,812.15. Get it? Okay. And let's see, will it qualify for 500 feet of fencing, right? So how many lengths? 2 of the lengths, right? So 2 times 125, right? Yeah. Plus, how many widths do we need? 4, right? 4 times, how much is each width? 62.5, right? 62.5, there we go. It's 500 feet of fence. Are we good, guys? Right? And let's see how it looks like, right? So on a graph, it looks like follows, right? Y is equal to what? 250 minus 2x, right? I'm using x in here because w cannot be possible for decimals. Are we good? Right? So seeing this one, I'm just gonna go to my settings and actually see how it looks like. On the x-axis, I'm gonna put what? 0 to width, right? So it looks like 62.5, right? So let's put in here 100, right? And for the y-axis, 0 to, what did we get a while ago? 7,000 something, right? So I'm going to put in here 7,500 just to see how it looks like, okay? Are we good, guys? Right? So seeing in here, that's the area with the length 250 minus 2w times w, right? As you may notice, it's going to give you the maximum area of how much? 7,812.5 square feet, right? When the width is 62.5, right? And the length is 125 feet. Are we good? All right. Other than that, the area will not be too much of a maximized, optimized area. Are we good? All right. Thank you.